So in our last video we discussed about variables, and I told you that you cannot declare a variable without a data type. So what is a data type? A data type in a simple form is used in declaring variables of or functions of different types. So these data types tell the compiler the type of information we want to store in a variable. So whenever you use a data type, it's simply telling the compiler the type of information that we want to store. And this data type determines several things in program. So what are the several things that this data type determines in program? So number one, whenever you use a data type, it determines the range of value that can be stored in a variable. Then secondly, it also determines the space and memory that a variable needs. And thirdly, it also determines the type of operation to be performed on that variable. So whenever you use a data type, it signifies so many things. One, the amount of size to create for the variable. Two, like I also mentioned, what type of operation to perform on it. So I will show you the list of data type we have in Arduino program. So if you look at the screen now, you will see the list of data type we have in Arduino program, and this data type that is showing on the screen will also show you the size it creates in the memory of the microcontroller in the Arduino board, and also show you the range it can store. So these are the list. So when you talk about void, just like void setup, that is a non it does not return anything, it just have a zero size. Then we have boolean, which comprises of one byte. So the size is just 1 byte, is either true or false, which is, if you talk about true, you mean 1. If you talk about false, you mean 0. Just it only requires only one information, either true or false. So if you look at the screen, you see the details is being displayed here, the sizes and the ranges. So I'll explain more when we start using some of these data type in our program. Just data type like a float, int. Like I said, that float data type is used to store a decimal number, and you can see that it has a 4 byte space. So whenever you use a float, it will create a 4 bytes or space in the microcontroller. So if you use a float to declare a variable, this is the space it's going to create in the microcontroller memory, and you can see the range of decimal number it can store. That is the range displaying on the screen. So you cannot go above, you cannot go below. So, and whenever you want to use an integer, you can also see that integer is used to store a whole number. So you cannot use integer to store a decimal number. If you want to store a decimal number, you use a float data type to store the decimal number. So whenever you use a float data type, the compiler will know that yes, you want to store a decimal number. If you use an integer data type, the compiler will know that this variable will store a whole number, and you can see the range of the number it can store, 32 minus 32,768 to 32,767. So you cannot go above, you cannot go below. Other data types also show you the memory they create, the size they create in the microcontroller, and the range of value that you can store in it. So that is it. Just like another data type I want to point out before I end this video is the double. So whenever you use this double is normally used with a float. So if you see the range of float number, the maximum range of this float data type, you will see the maximum. Then whenever you want to exceed more than that, whenever you want to store more than the maximum value that the float can use, then you use the double float. So whenever you use double float, that means you are doubling the amount of value that you want to store. it is also displaying there. So likewise, there is another data type I want to point out again, the long. You will see the long in the screen. So these few things that I'm calling now is the most used data type while declaring a variable. So we are going to make use of it as we proceed in this course. That's why I'm pointing it out. So if you look at this long, and this long can only store a whole number, but the difference between this long and integer is that it has a maximum capacity to hold more value than normal integer. So whenever you want to store more high value, you use long int. You must use long int. That long simply means a qualifier. It's telling the compiler, please increase more memory, increase more space. You cannot use only long. You must use long int so that the compiler will know that it is whole number you are talking about. So the long beside the int means increasing the whole number. And also you see unsigned int. That unsigned int means you want to store only positive number. You don't want a negative number. If you look at the normal int, you can store a negative number. You can store a negative whole number using the int data type. And also you can store a positive number using int data type. But whenever you want to store only positive, you don't want negative. Anything negative, the compiler will not accept it. Only positive, then you use unsigned int. If you use unsigned int, that means it can only store positive whole number and not negative. You can see it displaying in the table. So that is it. See you in our next video.